Welcome back to our videos on solving radical equations. Up to this point, we've looked at radical equations involving square roots. Now I want to look at higher degree radicals, or higher radicals with an index greater than 2, and also rational exponents in equations. So if I look at this example here, I have a fourth root. This is an index of 4. So I need to treat this a little bit differently. I'm still going to follow my same 4 steps. Step 1 is isolate the radical. So to isolate the radical, I'm going to bring the 6 over. So this is my step 1. 3 times the fourth root, 2n plus 6 is equal to 6. I'm going to divide both sides by 3 and get the fourth root of 2n plus 6 is equal to 2. I've now isolated the radical. I'm going to raise it to whatever power is necessary to get rid of it. To get rid of a square root, I squared. To get rid of a fourth root, I'm going to raise it to the power of 4. The power of 4 is going to undo a fourth root. The power of 16 would undo a 16th root, and so on. So the left-hand side is 2n plus 6. That is equal to, I can either pull out my handy table and see that 2 to the 4th is 16, or I can count it out on my hands. To the first is 2, 4, 8, 16. So this is 16. So now this was step 2. I'm now going to work on step 3, which is solving this equation. Subtract 6 from each side, divide by 2. So I get n is equal to 5. Step 4 is check. You still have to check. You always need to check these. So 3 times the fourth root of 2 times 5 plus 6 minus 6 equals 0. 2 times 5 is 10 plus 6 is 16. So I want the fourth root of 16 minus 6. What raised to the fourth is 16? That's 2. So 2 raised to the fourth is 16. So this becomes 3 times 2 minus 6 equals 0. 6 minus 6 equals 0. 0 equals 0. This works. I'm happy. That's my solution. Let's take a look at another example. In this case, instead of having a radical, I actually have a rational exponent. It works exactly the same way. Isolate. So step 1 is isolate. I'm going to isolate by adding 4 and then dividing by 2. So I'm now at the step 6x minus 3 raised to the 1/3 is equal to 2. I need to raise this to whatever power is necessary to get rid of 1/3. If we remember back to our properties of powers, if I raise a power to a power, I multiply. So to undo a 1/3, I'm going to raise this to the third power. So a rational exponent of 1/3 is the same thing as a cube root. I said to undo a cube root, we would cube it. To undo a 1/3 exponent, we would raise it to the third. 6x minus 3 is equal to 8. So now I'm going to solve. 6x is equal to 11. X is equal to 11 over 6. I'm going to go back and check this. 2 times 6 times 11 over 6 minus 3 raised to the 1/3 minus 4 is equal to 0. 6 times 11 sixths is going to be 11. 2 times 8 to the 1/3 minus 4 equals 0. Only 8 is being raised to the 1/3, and if I remember back, 2 cubed was 8, so 8 to the 1/3 should be 2. So I end up getting 0 equals 0, or x equals 11 sixths is my solution.